Our next topic is bidirectional shift registers with parallel load. Okay, this is the diagram, the logic diagram. Here we have used the flip flop D flip flop, and we have used 4 flip flops as well. And how does it work? Okay, and what do you mean by bidirectional shift register, by the way? Okay, bidirectional shift register. As the name implies, here the data bits can be shifted from left to right or from right to left. That is, in the case of bidirectional shift registers, data can be shifted from right to left or left to right. Okay, and here we have mainly two signals. One is D in, it stands for data. Okay, input data, and the other one is right bar left bar. Right bar left bar is the mode signal. Mode signal. When we see this figure for the first time, it can be a bit complex, but it's very easy when we draw it. Okay, I will explain how it is. This structure, for each D inputs of the D flip-flops used, we have two AND gates followed by an OR gate. If you have followed the concept, if you have learned control buffer register, it will be clear. As I told, either one of the AND gate will be active and the output will be transferred through the OR gate to the next case. I have already explained how it happens. Okay, so what we need to do is, here we have 4 flip-flops. So based on that, we will have 2 AND gates in each section. Okay, and we also have an OR gate following it. So we'll name the AND gates as G1, G2, G3, G4 and G5, G6, G7, G8. Okay, G1, G2, G3, G4, G5, G6, G7, G8. Okay, so what about the working conditions? Okay, so here the concept is clear that we are going to transfer the data either from left to right or from right to left. Okay, so we also have a data. So right slash left bar means the which is the active high pin. This is right. Okay, so when this is the pin, okay, right bar left bar, we have a negation part, we have the original part. Okay, so when value 1 or a high is given to this particular part, we know that it's right shift, right will be activated. That is, if there is a 1 on that particular case, right operation or the data will be shifted right. That is, when the value of right slash left bar is 1, it acts as a shift register. Okay, so when it encounters a 0 or the value given to that particular pin, not encounters, even the value given to that particular pin is 0, what happens? We know that it's active low. Okay, so left will be activated. Okay, so the circuit acts as shift left shift register. Okay, so data is given to the first gate G1 and also the last gate G8. So D in is given to G1 for in the case of right shift register, and D in is given to, or the data is given to G8 in the case of left shift register. Okay, and how does it work? Once again, when right slash left bar is high means value 1, it acts as shift right shift register, right? So what happens is, D in is given to this particular value G1, that is gate G1, and it's high means right will be activated. Okay, right operation will be activated. So D in is there, R right operation will also be activated. It is given to through the gate G1 to OR gate to D1. Okay, then this will be ready to be fed to the next gate G2. Here also right will be connected to that particular case. Okay, so what happens is, first we have the when the value of right slash left bar is high or low. Okay, so we have the arrangement, the necessary arrangements, and we also have a clock pulse. During the changes that happens in the clock, what happens is the data which is already available in this particular flip-flop will be transferred. I mean systematically transferred to the next flip-flop. I will explain once again. Right slash left bar means when it's high, it means right. So what happens is this is activated and we have D in through OR gate to D1. Then Q1 will be fed to G1, G2, and G2 is also connected to right. So again we have the OR gate D2, Q2 will be fed to G3. G3 is already connected to, again G3 will already be connected to the right case. Okay, through OR gate D3, Q3, and Q3 will be again fed to G4. Okay, and by the way, G4 is already connected to what? The right shift. Okay, so through OR gate to D4 to Q4. Okay, don't think about how these values will be shifted. Okay, here it is already for the right shift is already shown how that Q4 will be shifted, right? But in the case of left shift, it's not shown. So as I told once, these are designs. Okay, there are the design diagrams or the logic diagrams. We can't say that how that particular operation takes place. In many cases, we can't give the proper explanation because it's all about the design. Okay, in the practical case, we will definitely see the bits shifting right and also shifting left. And how does the left shift works? That is, when the value given to right bar's left bar is 0. Okay, 0 means we have left bar. When the value left bar means it's active low pin. So when 0 is encountered, it's we will have the left operation. Okay, left shift operation. So we already have a connection D into G1. At the same time, we also have connection at G8. Okay, it means that a G8 is connected. Okay, with G8. What is connected to G8? See, G8 is connected to the negation part. G8 is already connected to the negation bar. At the same time, it's also connected to D in, the data. Okay, so through G8 to OR gate D4, Q4, we have the Q output. So what happens is this will be fed back to the right gate. That is the right AND gate, which is G7, and G7 is already connected to the negation part again. Okay, so we have the OR gate D3, Q3. Q3 is again taken left to G6. Okay, G6 by the way is already connected to what we call the left shift. Okay, so again OR gate D2, Q2, again this is fed back to G4, G5. G5 is already connected to, okay, this particular case. Here the Q1 is, it's that's what I told. Here we can't give the perfect shifting, but we have already understood that the data which is the D in which is already given to G8 is shifted left. Okay, so what we need to understand from all these cases is bidirectional shift register means a circuit that supports both these cases. Okay, but at one time it supports only one operation. Okay, so when it's high, this pin is high, the mode signal is high. When it's right is activated, the signal will be given in this particular fashion. It will be shifted in the right position. And when it's left shift, we have already D in and we have D4, Q4, and this Q4 will be shifted, given to left. And again, this happens to G6 and this again is fed back to G5. Likewise, the bit is systematically shifted leftwards. Okay, please go through.